We're going to take a look at graphing and solving linear inequalities. Simply put, an inequality is just like an equation, except instead of an equal sign, it has an inequality symbol. Inequality symbols you're familiar with: less than or equal to, greater than or equal to. The way we begin is by taking a look at the inequality that's given to us. Now, as I go through this problem, you might find the need to pause the video as you're constructing your graph, and that's fine. The first thing that I've done is I plot the y-intercept of 5, and then I use the slope of -2/1 to plot some additional points. Once I've done that, I construct my line. So far, there's nothing new. The new part is that we need to do some shading. This is greater than or equal to. When I think greater than or equal to, greater than makes me think up. So what I do is I put a pencil somewhere on the line, and I draw a little arrow upward. That upward arrow shows me the direction that I'm going to be shading. And since I'm shading up, I'm going to shade right over in this section here. We usually denote the solution set, the area that's shaded, with the letter S. S stands for solution set. In other words, pick any point that's in this shaded area: 0, 10, 10, 5, 13, 15, any point that's in the shaded area, and plug it into this inequality. You'll find that the value that comes out of it will be true. There's a couple of interesting things to discuss when we're talking about linear inequalities. Firstly, an inequality is never a function. Rather, it fails the vertical line test. In fact, the vertical line, the part that's blinking yellow, that whole section is failing the vertical line test, so it can't be a function. If we picked x equals 4, it could spit out a 0, a 1, a 2, a 3. It's clearly not a function, just thinking back to our function maps. The second one is for you to try. Now notice here there's something a little bit different. Y is less than 4x plus 4. There's no equal sign. It's not equal to anything on that line. It's just less than. So when you construct the line, it's going to be a dashed line. Also, when you get to the point of shading, you're going to be going downward. So you'll put your pencil on the line and go downward, because less than makes me think downward. That'll show you which area to shade. Please pause here and give example 2 a try. Let's see how you did. The first thing I did was graph the line 4x plus 4. Y-intercept at 4, and the slope was 4. And so I constructed the line. Notice that the line is dashed, showing that none of the points directly on the line will make this true. Then I had to decide where to shade. I put my pencil on the line. Less than makes me think of going downward, and so I drew a little arrow downward, and that showed me the area where I was going to shade. I shaded that region in and labeled it with an S for solution set. We're going to try just a couple more examples. We're going to jump around the packet a little bit in a moment. The third example is y is greater than -4/5 x. Remember, -4/5 x is really -4/5 x plus 0. So we do have a y-intercept, and we do have slope. Once again, because it's just greater than, it's going to be a dashed line. Please pause the video here, and let's come back and see how you do. Here we go. Let's take a look. We have our line, -4/5 x plus 0. And because it was greater than, I put my pencil on the line. Greater than makes me think upward. And so I shaded above the line, labeled it with the S for the solution set. Notice that once again, this is not a function. It fails the vertical line test. It cannot be 1-to-1 because it's not a function. Finally, example 9. I'm going to ask you to flip forward a few pages. Example 9 is something worth noting. The first thing I'm going to do here is get this into slope-intercept form. And so I have 3x minus y greater than or equal to 5. I subtract 3x from both sides, and I have -y is greater than or equal to -3x plus 5. However, notice that my y is not alone yet. I have negative y. And so that's negative 1y. I have to divide everything by negative 1. That gives me y, positive 3x, and negative 5. But notice something strange, kind of special happened here. We had a greater than or equal to symbol, and it changed to a less than or equal to symbol. Think about what this means. If the opposite of y is greater than, then y must be less than. As a general rule, when you multiply or divide by a negative number, the inequality flips. So if you want just a simple rule, multiply or divide by a negative, flip the inequality symbol. But if you think about why that happens, it makes perfect sense. If the opposite of y is greater than, then y itself must be less than. Then I simply graph, shade, and label the region. Now, it may be possible that you want to try a few more examples. There's a whole bunch of examples in this section. I encourage you to try as many as you would like to. Remember, the worked out solutions can be found on the website under the Notes and Home Fun Packet section. So as you try some additional problems, you can go in there and take a look and see how you did. And this is everything you need to know about working with basic linear inequalities.